In 4, we're given the equation p minus 2 bracket x squared plus 8x plus p plus 4 equals 0, where p is a constant. And this equation has no real roots. And in part A, we have to show that p satisfies this equation, this inequality, and then in part B, we have to find the set of possible values of p. Now, to solve this question, we need to know the simple quadratic equation, which we can use, and in the quadratic equation we have a specific term called the determinant, which we're going to use here to solve the first part. But I'm just going to move this question to the side because it takes up a lot of space. So there you go. Now I'm going to write the equation. So if I look at this equation is a quadratic equation because it has an x squared term, then it has an x term, and it has a constant here. The first term, which is written with x squared, is often referred to as a. Here it is p minus 2, so I can say that a is equal to p minus 2. B over here is 8, and c is p plus 4. The quadratic equation is given by this: x equals negative b plus minus the root of b squared minus 4ac divided by 2a. This part of the equation, b squared minus 4ac, is known as the determinant. And because it's in the square root, if this term is equal to 0, we have just one root to the equation. And if it's negative, we don't have any real roots, because the square root of a negative term does not give us a real number. And if it's positive, if it's greater than 0, then we've got two real roots. So here, because in the question it's mentioned that it has no real roots, we know that b squared minus 4ac would be less than 0. So I'm going to write that down here. B squared minus 4ac less than 0. Substitute the values of b, a, and c. So we've got 8 squared minus 4a, which is p minus 2, and then c, which is p plus 4, is less than 0. 8 squared gives me 64, and then minus 4, and if I multiply these brackets out, I've got p squared, then I've got plus 4p minus 2p, so I've got plus 2p, and then negative 2 times positive 4 gives me negative 8, less than 0. 64 minus, multiplying this out, I've got 4p squared, and then I've got negative 4 times 2, 8p. Negative times negative gives me positive, and then 4 times 8 gives me 32, is less than 0. Moving on, I can add these constants up, 64 and 32, so it would be 64 plus 32, which is 96. And the term with p squared is a negative term, but I want it to be positive. So I'm going to move all of this to the other side of the inequality, or we can say that we will divide this by -1, which changes the sign of the equality. So I'm going to show you guys what I mean. I'm going to first write it down as negative 4p squared minus 8p plus 96 is less than 0. Now we've got a common factor between all of these, which is 4. We've got 4 times 1, 4. We've got 4 times 2, 8. And we've got 4 times 24, 96. So I'm going to take 4 out as a common factor. But I'm also going to take negative out there. So because I'm dividing this entire thing by negative 4, I'm also dividing this side by negative 4, technically. So I'm going to change this sign, which is less than, to the sign greater than. So what I'm basically doing is dividing this by negative 4. So it would be negative 4p squared divided by negative 4 gives me p squared. Negative 8p divided by negative 4 would be positive 2p. And then 96 divided by negative 4 would be negative 24, greater than 0. I hope it's clear. If you want to do it the other way, what you can do is basically bring all of this out to this side. So when you say that this is negative p squared here and it goes on the other side, we're basically adding 4p squared to both sides. So we write here plus 4p squared and here as well plus 4p squared. And then here we do the same thing. We add 8p, so we write 4p squared plus 8p, and then we subtract 96, so we write negative 96, and we were left with 0 on this side is less than 4p squared plus 8p minus 96. And then because 4 is a common factor, we divide by 4, and we get the answer of p squared plus 2p minus 24. And we can flip the equation to write the equation on the left side and then the 0 on this side. So it's this equation is greater than 0. Okay, I hope it's clear.